Hello friends, how are you? Today we are going to learn about Euclid's division algorithm and use it to find the highest common factor of two given positive integers. So to apply the concept of Euclid division lemma in well-defined step is known as Euclid division algorithm. We already know to find the HCF of two given positive integers by our old methods like division method or prime factorization methods. But we can also find it by Euclid's division algorithm. What is algorithm? Algorithm is a series of well-defined steps. So to understand HCF by Euclid's division algorithm, we first want to recall what is the HCF of two given numbers by our old methods like prime factorization method. So let's recall first. So let's take the HCF of 455 and 42 by prime factorization method. We get the factors of 455 is 5, 7 and 13, and 42 we get 2, 3 and 7. So we get the HCF of 455 and 42 is 7. Now we are going to find out the HCF of two given numbers by Euclid's division algorithm method. Let's take again those numbers 455 and 42. 455 is greater than 42. Assume 455 is the dividend and 42 be the divisor and divide them. When we divided 455 by 42, we have got 455 equals to 42 into 10 plus 35. So remember, here remainder is not 0. So we consider the divisor 42 is the new dividend and 35, that is remainder, is the new divisor and divide them. So we have got 42 equals to 35 into 1 plus 7. Here remember that the remainder is not 0, that is 7. Now proceed further. Now consider the divisor 35 is the new dividend and let's 7 remainder is the new divisor and divide them. So we get 35 equals to 7 into 5 plus 0. Notice that the remainder now has become 0 and we cannot proceed any further. The equation we have got 35 equals to 7 into 5 plus 0. We claim that the HCF of 455 and 42 is the divisor at this stage, that is 7, because here the remainder now has become 0. We can easily verify this result by our previous result of computing the HCF by prime factorization method. Now we proceed to verify by our previous results of prime factorization method, and we have got that is exactly the same of by our Euclid division algorithm, so we can verify it. Now in a formal way, let us state the Euclid's division algorithm clearly. To obtain the HCF of two positive integers, say c and d, with c is greater than d, follow the steps like we do in our previous case. Step 1. Apply Euclid's division lemma to c and d, so we find whole numbers q and r such that c equals to dq plus r, whereas r is greater than and equals to 0, but it is always less than d. Step 2. If r equals to 0, d is the HCF of c and d. If r is not equal to 0, apply division lemma to d and r. Step 3. Continue the process till the remainder is become 0. The divisor at this stage will be the required HCF. Now we claim that this algorithm works because HCF of c and d is equals to HCF of d and r. That is like in our previous example, that is HCF of 455 and 42 is equal to HCF of 42 and 35. That is our answer 7. Now, lastly, Euclid's division algorithm is not only useful for calculating the HCF of very large numbers, but also because it is one of the earliest examples of an algorithm that a computer had been programmed to carry out. Thank you.